Hello everyone, welcome back. Today we're going to repair a problem which is entirely caused by my own stupidity. So before we start, a bit of context. I haven't been able to put out a lot of videos lately because I'm working on moving some of my pinball machines which are in storage into the house. So that took quite a bit of work. At the same time, I'm also renovating one of my arcade cabinets. You can see it in the back there. If I twist the camera a bit, yeah, see, there it is. That didn't need a lot of technical repairs, that just needed a lot of cleaning and lots of updating of the cabling, because I did the cabling on that thing 15 years ago. It literally was the first electronics project that I did when I started with this. Okay. It literally was the first electronics project that I did when I started this hobby. So let's say the cabling and especially the soldering was below par. So I decided to redo all of the cabling. So I'm working on that, and it doesn't really make of an interesting video. It's just, well, soldering new wires and putting new cables and connectors. So I didn't think it was necessary to make a video out of that. However, in the process of moving my pinball machines, I noticed that one of my machines suffered damage from some leaked batteries. Which is a bit of a shame, because this machine has been in my possession also for about 15 years, I think. And the damage is basically my own fault, because I didn't swap the batteries on time. So we're gonna have a look at that in this video. So if you're one of my regular viewers, chances are high that you're not really into pinball machines or arcade machines. So don't worry, I'm gonna give a bit of context. This is the MPU board, so this is the main processing board of my Judge Dredd pinball machine. This is a pinball machine from, I think, 1993, 1994. So this is basically the computer of the game. It has the CPU, the ROM with the game software, and the RAM. And it basically handles all the logic, and it's connected to the other PCBs and the other parts of the pinball machine that, well, activate the lights and the coils and the switches and everything. And as you also noticed, there are 3 batteries that keep the RAM alive, basically. There are quite a bit of settings in a pinball machine like this, as well as high scores that need to be saved. And that's why they have here battery to, well, retain the memory of the RAM. And as you see, these batteries are leaked quite badly. So I brought you in a bit closer so that you can have a look. Here, it's especially this one which has been leaking, and you can see battery leakage here across the board. Now this PCB sits upright in the machine, so it sits like this. So that means that the battery damage leaks downward. So that's why if you have a PCB like this with battery damage, most of the time it is only located here in the bottom section of the PCB. And if it is really bad, it also finds its way upwards. But, well, I've repaired boards like this, which are much worse in battery damage than this one. And it's most of the time this area only which is affected. Now, luckily, there is not a lot of exotic components here in this area. So you have these ICs, they are LM339s, this one, that one, and that one. So these are very common. That's a ULN2803, that's also a common chip. So if we need to replace one of these, that's not going to be a big deal. For the rest, these are just resistors, diodes, and capacitors, and they are all very common values. So there is absolutely nothing, well, problematic or that you cannot replace anymore. It only starts to get a bit more annoying when the battery leakage goes down very far, and it also reaches these connectors, because then you're going to start to replace connectors, and not only on the PCB but also the connectors itself in the machine that plug into these headers. They can get damaged by battery corrosion, and then, yeah, it starts to get annoying to make new connectors. But this is just a matter of replacing resistors. See, here you can clearly see the extent of the leakage. So we have some corrosion here on these resistors and these 2 ICs, and those resistors as well. And that I see we also have some tiny specks of green crust on some of the legs. That shouldn't be an issue. These ICs are maybe a bit more problematic. And these resistors, I don't know, we'll have to see when we clean this up. And if there are any damage traces somewhere. Difficult to say. At the moment it doesn't really look too bad. I've seen much worse. I really had cases where I had to replace everything here in this bottom section. So every single resistor and diode and capacitor and all the chips here. And in that case, that machine has been in storage for 10 years or so, 15 years, without the owners even knowing that there were batteries inside. So yeah, here I don't have an excuse. I really should have checked the batteries and I should have replaced them timely. I think I replaced these, or I checked these 2 years ago, and at that point they were not yet leaking. So, and now, well, they clearly are. Okay, so first thing I'll do obviously is dispose of these batteries. And when they are gone, I'm gonna also dispose of the battery holder. See, it's this one that leaked really badly. Yeah. Okay, here you can clearly see that we have a bit of a problem. Now, first thing I'm gonna do is simply desolder that battery holder. I think it's best to just take it out and leave it off. And here on the bottom side, I don't see any signs of corrosion, so there is nothing that came through the PCB, through a via or anything, or to a solder connection, so that's already good news. So first thing is I'm gonna add a bit of solder to the 3 solder points of the battery holder, just to have some fresh solder on there, so that yeah, I can desolder them much more easily. Okay, so there is a lot of old solder that came out, but definitely not everything. I'm gonna clean this up further with some wick. I think these are loose, almost. Let's say 99% of the solder is out. And now it's these 3 guys. This one is almost already completely empty. Yeah, the pads are coming off here on this side, but that's not a big deal because we're not gonna install a new battery holder anyway. Wow, we have a lot of spilled nastiness from the battery leakage. So what I probably should have done here is snap off the leads of the battery holder because, well, it's ruined anyway. So I'm just gonna snap the leads. That's gonna make things, wow, a lot easier, I wanted to say, but those leads are very sturdy. Wow. These are not going to be snapped. Damn. Nope. Just gonna heat them up, voila. There they are. Now this side as well. That's gonna be more difficult because we have the corrosion on this side. Oh, these are coming out. That one is very badly damaged. There we are. Okay. Okay, so now we have a much better view on the situation. I think it's still rather limited. It's basically this area over here. Now, first thing I'm going to do is neutralize this with some vinegar. And then you'll see that it will probably start bubbling nicely. Well, you can even hear it. and you can see it bubbling away. This is just some simple household vinegar. There isn't really a need to use anything stronger or anything less strong. There is no need to dilute this with water. I'm just gonna let this sit for a while, eating away on the battery leakage, and then we'll come back. So I'm gonna grab a coffee, and when I'm finished my coffee, I'll clean this up and we'll have a look at the exact damage that has been inflicted. But at first sight, I think it's gonna be pretty okay. Okay, I think this has been sitting long enough. Time to rinse it off with some demineralized water. First, I'm gonna dry it up as much as I can with this old piece of cloth. And here we come with the demineralized water. And I'm just gonna tilt it a bit in that direction. That way I hope that I can preserve these stickers over here. And I'm already starting to see that as of this row of resistors, everything seems perfectly fine. There is absolutely no, well, I think all the leakage, battery leakage, the corrosion came off quite well. So what does this section of the board do exactly? Well, this is all handling of switches. So all the switches that are scattered all over the playfield in a pinball machine, they are connected here through these connectors. And then, well, these resistors and diodes and capacitors, they are part of the switch matrix. And these ICs, they basically couple the switches to the CPU. So that means that if something is bad in this section, you will see, well, switches that don't work, or the pinball machine that is not able to read out the status of most of the switches or a large amount of the switches. Or yeah, you will not be able to start the game because the button to start the game, the switch cannot be registered for that button. So these kind of issues. Now it is important that you rinse this off quite well. I've already done 2 passes because, well, you don't want to leave any vinegar underneath the ICs, because that could cause damage as well in the long run. I'm going to try to blow a bit of air. This is cold air that I can put a bit of heat on it. That's not a problem. So I'm going to to dry this up more quickly, and to also dry it up underneath the ICs a bit more quickly. See that how much water or vinegar or whatever it is that is still underneath? In any case, you really have to let this dry out thoroughly before you test the board again, obviously. Now the thing is, I haven't tested the board before I removed the batteries, or before I took it out of the machine. So I should have done that, perhaps, because it could very well be that there is nothing wrong with this board. Okay, let's have a look at the situation. You can clearly see that here we have some corrosion on these legs. I think these 2 ICs are the ones that got hit the worst, but I'm not sure if it's going to be a problem. Because if the corrosion didn't get into the IC, then we might well be fine. Well, yeah, sorry that I'm going out of view from time to time, but I really need to look close to the PCB. See, so these resistors here, all the legs of these resistors, they are quite tarnished. They are dull and not as shiny as these guys over here. So, but that also is not necessarily a problem. Here there are some black spots. I don't know if that is corrosion that got underneath the solder mask. No, it's just some corrosion sitting on top, or some staining on top of the solder mask. So That also looks fine. I think I caught this issue just in time. Here we have some black spots on this trace, but it's also not underneath the solder mask, because if I scrub them away, then the trace is just fine. So that seems to be okay as well. Well, there are some traces running underneath these ICs. That is always a bit of a guess if they are okay or not. Yeah, the trace is fine. This one, that's not the correct. Going to here somewhere, yeah, to there. It's also fine. I think really we caught this just in time. Yeah, that one is also fine. That one as well. That one as well. So those are the main ones that run underneath this IC. So from these resistors, they go, see, from that pin to that pin, from that pin to that pin. They run underneath there, and then they go underneath the IC. I think all of these are okay. Here, it's probably going to be the same thing. Yeah. Yeah. These look fine. So if the ICs are not damaged, then I guess we are okay. It doesn't look pretty, but I think it's going to be okay. Simply going to clean this up a bit more with isopropyl. And then we can put it back in the machine. Oh well, I'm just going to let it dry for a couple of hours, and then I can put it back in the machine and see if it works. So I'm here at the machine, and I can imagine that if you've never seen a pinball machine on the inside before, that this can look quite intimidating. There are multiple boards here in the back box. The big one over here, that's the power driver board. So that has the power supply. It also drives all the solenoids on the play field and the lighting, both just the illumination and the feature lights. And it can also dim the lights. So everything basically which is high current, let's say, and power supply is on this big PCB. On the top left, that's what Williams, because this is a Williams pinball machine, called the Fliptronic board. That's a dedicated board just to control the flippers. This is the sound board, and that's the dot matrix display board. So here we have the dot matrix display, and that's the driver board for the display. In this long gap you see over here, that's where our CPU fits, that I just, well, hopefully repaired. So I'm just going to put this back in, connect it back up, and then we'll see if it works. As you see, the data control of the CPU is done via these ribbon cables. So we have one ribbon cable over here going through to this section basically. And then there is one here going to the power driver board. And there is this one. Should go like this. Okay. And then here we have a connector for the power supply. So this simply supplies ground 5 volts and 12 volts to the CPU. And then here we have all the connectors for all the switches. And I've labeled them before I took them out. Like that. See, these two headers, they are not connected. Keep in mind that these board sets was generic for a certain generation of pinball machines. So that means that not all connectors are always used, because some machines have more or less switches than others. So in this case, these two top connectors or headers, they are not used. Okay, I think I'm done. Let me put the display board back so that we can see if we see something on the display. And let's plug this thing into the wall, right? If you want to watch for something blowing up, here are the fuses. I hope that won't happen. So if it works, if the CPU boots, then we should get an error message on the screen saying something like factory settings restored, because, yeah, of course we took out the battery. Okay, let me turn it on. Yeah, factory settings restored. Bookkeeping totals cleared, so the machine is booting. That's already good. Now I need to go outside the shot, outside the video, because I need to operate the test button. And of course my light is in the way here. Let's see. Yeah, it can already read the test switch, that's nice. Okay. Time and date not set, that's normal. The test switches are working. Since the battery damage mainly influences the switches, let's just go into switch test immediately. Switch edges. Okay. Just gonna activate some random switches on the playfield. Oh, what the hell? That is not... Fourth coin option. Okay, yeah, there is definitely something going on here. Yeah, see, there are definitely issues. See that there is a switch blinking? That's this fourth coin option switch, but that's a switch that is not used. See, so now the machine is just simply showing which switches are closed, and here on the screen you have a display of the switch matrix, and you see that there is something flashing in the leftmost corner. Now the leftmost corner are switches which are not in the matrix, in the switch matrix. Those are switches which are directly connected to the CPU. So I'm just going to unplug that cable of the directly connected switches and see if we still have that problem. I assume, yeah, that's that one. Let's see if that makes a difference. If that doesn't make a difference, then we have a problem on the CPU board. But problem is now, will not be able to get into the test menu because I need the directly connected switches to get into the test menu. Wait, I need to I'm gonna unplug that connector while the machine is running. See now? Yeah, there it is again. See, fourth coin option. Could also be a cable pinched somewhere. Let's just unplug this connector. Yeah, still doing it. Still doing it. See, now I have all the connectors disconnected, so the CPU board doesn't even get any input from anywhere, and it's still constantly registering this fourth coin option switch. So yeah, let me turn this off because this is bloody annoying. So there is an issue on the MPU, probably due to the battery leakage. I'm just going to have a look at the service manual, or well, the schematic, and try to pinpoint exactly where the problem might be. Yeah, so back to the workshop. Okay, so I'm back in the workshop, and I do have here on the screen the schematic of the CPU board, and the switch input that was acting up was direct switch number 4. And I've already located it on the screen. It's over here. So see, here we have the connector J205, and direct switch number 4 is connected conveniently to pin 4. It comes over here via this connection, goes here through this diode, D18, then there is a capacitor to ground, and then there is a pull-up resistor. Well, this is drawn not that obvious, but this line here going up, I can show you, is a line to 12 volts, and this one is a line to VCC, and then it goes through this resistor into the input of this comparator in the LM339. And then the output of this LM339 goes to, here is an LS240, and then you have the data bus line for the CPU. So there is not much in the pot, right? So there is not much that can go wrong. So my immediate suspect would be here this LM339. So that is chip U17. Let's have a look where that one is located. Unsurprisingly, U17 is this guy, and this is U16, and these are the two LM339 chips that handle the direct switches from this connector. So yeah, these both ICs, they really get the mother load of all the battery leakage. So I suspect that something is wrong here with at least this guy, probably also that one. What I could do is I could hook this up to the bench power supply, power the PCB up on the bench, because that is possible. You only need to supply ground 5 volts and 12 volts here on this connector, and the CPU boots. It doesn't need anything else from the pinball machine. It does boot like that. Then I could probe here with my oscilloscope. I could probe the inputs and the outputs of these chips, and then I could really validate that these are indeed faulty. The thing is, I'm not gonna bother because these really had so much battery leakage that I think it's not a bad idea to replace them anyway. If they are not faulty, they might be faulty at some time in the future. Maybe there is also some battery leakage underneath, but more importantly, these are extremely common chips that are really easy to buy. And now if these were expensive RAM chips or something which was unobtainable, then I would really troubleshoot a bit further to see if they are really faulty before I take them out. But now I'm just gonna take them out, replace them, and then see if that solves the problem. Honestly, the best way to replace these guys is just by snapping them off and then desoldering the pins. That's really the safest way to, if you know that the chip is faulty, to really get it out of a PCB. And you do that by cutting the pins as close to the casing of the IC as you can, because you do need a bit of pin left to easily get them out of the PCB. And you can see that the board looks very crusty underneath. The pins, they are really corroded quite heavily. And now again, the same trick as before, just applying a bit of fresh solder to each pin. So I found out that it's quite easy. If you put a bit of fresh solder on the tip, you just push them through from the bottom side, and then you come here from the top, and then they just lift out. And you can take them out easily, one by one. And now it's time to clean it up, clean everything up with some solder wick. Yeah, I should have used the solder sucker instead, because this is consuming a lot of solder wick. Yeah. And now we can still clean the remnants with some solder wick, right? Yeah, I should have used the solder sucker first, because that was a bit of a waste of solder wick. Oh, there is one hole still filled. And next I'm gonna clean up this flux. And now you can clearly see the amount of traces that are here underneath these ICs. So it is very, well, treacherous to just leave them be and not check what is going on underneath, because every time when I have a heavily battery damaged board like this, then these traces underneath this IC U16, they are, every time there are breaks and, well, damages in these traces. So yeah, if you have a lot of battery damage, you have to check every single trace, and you also have to check every continuity of every through hole for the IC, that top and bottom are making good contact. This side is looking perfectly. So what I'll do next is I'm going to check all these traces. Because see, for example, this guy, is it still connected or not? See this trace coming through here? It's not connected anymore to this battery terminal. And I think that's supposed to be ground. Let's see. Yeah, I think that's ground. So that's the... but it's probably still connected via some other way. See? See, they look fine. But I'm gonna check them anyway, just to be sure. Well, I checked all the traces and I think everything is fine. So next step is soldering in some sockets here for the new LM339s. Everything looks good. Now for the LM339s that I still have in my stock, I only have one new one. And the other ones, they are pulls from other PCBs. I think these are even desoldered ones. I must have desoldered these at some point, because there is some solder here on the legs, so I'm not going to use these in a socket. If I ever have a project where I need to solder some ones directly into a PCB, I'll use these. But since I only have one new one, I'm going to use these guys. These are also pulls. These are recycled, but I guess they should still be fine. And yeah, the advantage is that we don't need to straighten the legs, because they are already in the perfect shape for a socket, because they originally came out of a socket. Oh yes, one more thing. I just soldered in a battery holder for a coin cell, because just in case, if this works and I don't need to repair anything else, then I don't need to take the board out of the machine a third time. So I just soldered in here a battery connector just in case, and or a battery holder. And I'm going to use a coin cell for now. It's just a temporary solution. Here in the back side of the PCB, I did have to solder, where is it? Here on this side, I had to solder the battery holder to a trace, because this pad is completely gone when I removed the battery holder that came off. So I had to solder it here to a trace, but that's it basically. So okay, let's get this back into the machine. Okay, the board is back into the machine and everything is hooked up, except I left the full switch matrix disconnected. I only connected the direct switches just to make sure that I can go into the test menu and yeah, see if everything is working fine. Okay, time to turn this back on. Oh, I think that's maybe a ribbon cable issue. Yeah, I do know that this ribbon cable here, this big ribbon cable, you see this is the, like I explained, this is the board for controlling the display, the dot matrix display board. So the data from the CPU to this board goes through this ribbon cable. And I have noticed in the past that this ribbon cable is going bad. That is something really common with these machines, that if you plug and unplug these ribbon cables often, or well, not even that often, maybe a couple of 10 or 20 times, then they start going bad. I do have a spare one in stock. I bought a spare one years ago, but I haven't used it yet. But those lines on the screen, those were just simply the ribbon cable here going, well, not making good contact. The machine boots. Now I have to go to the test button. Okay, well, yeah, that is okay. Yeah, that machine was acting weird, probably because the switch matrix is not connected, but let's just get into the... I pushed accidentally the wrong button. I pushed the button to start up the machine instead of going into the test menu. Let's go into switch edges. That honestly looks fine. Ah, no, it's still doing the same thing. Oh, come on. Right, I'm back here at the workbench and I've been checking this PCB here literally for less than 5 minutes and I think I found a problem. Now, it's a pity that I didn't put it on video because I think it would have been a nice aha moment. Let me explain you what I think is wrong. So I started back from the schematic, which is something that I should have done in the first place. And again, the problem that we were having was with this directly connected switch number 4. We will follow the line over here. Remember, it was also being flaky when this connector was simply open, so not connected at all. So that means that, yeah, this diode will probably not be the problem. So we can already skip that. Here we have a capacitor C26. If that one is shorted, then this entire line could be shorted to ground. So that's a potential issue. Let's check this first. Now the thing with this PCB is all the components are nicely labeled, but the problem is the resistors and the capacitors are labeled underneath the components. So it's really difficult to deduce which resistor and capacitor and diode is which. And that's why I found this really nice drawing of the entire board, which someone made and is available on PinWiki, where we have all the components nicely labeled. So the one we were looking for, the capacitor, well, let's do all of them at once. Capacitor C26, here we have resistor R62 and R47. Let's start with capacitor C26. And that one is over here. So you see this is quite far away from where the battery leakage was. The battery leakage was in this area. So I really doubt if this is going to be a problem. So C26 is this guy, and I have my multimeter on continuity, and it's fully open. I don't measure anything at all. Let's just put it on normal resistance measurement, 7 megs, and let's test some other capacitors, 7 megs. 7 megs, so there doesn't seem to be anything wrong with this one. So this is the C26, and then next we have this pull-up resistor R82, and then the inline resistor R47. I think I said R62 earlier, but it's not R62, because R62 is over there. This is, well, it's you can read it quite badly, but it's R82. That should be a 1.2K, and R47, which is the inline resistor to the LM339, R47. So R62, 82. It's this guy over here, also quite far away from the battery leakage, so I guess that won't be a problem either. Let's measure this. And you can see my multimeter, but it leads 1.2K, which is exactly correct. The other one was, I think, R47, right? Yes, R47. That one is located over here, just below the LM339 and really in the battery corrosion area. So that might be a problem. R47, that's this guy. And we measure 1K, perfectly fine. So then I went happily along. See, we are coming here from R82 and R47 into U17C. And then we go out and we have a pull-up resistor R41. R41 is located over there, still in this area of battery corrosion, so R41. Okay, that should be 10K. These ones, they are labeled next to them, so that is a bit more easy. And 10K, if you don't believe me, R41, 10K, perfectly fine. And then, so this is fine. Up until now, everything is okay. So then signal path continues, and we end up here in this LS240, which is this chip over here. So I started thinking maybe that chip is bad. But before we start checking if the chip is bad, I figured let's maybe check continuity. So let's see if we have this continuity here between these resistors and the LM339. I've checked all the traces and all the continuity when I replaced the LM339, and everything seems okay. I didn't go beyond that. So let's check if we can go from this side here of R41 or pin 14 from U17C. If this is connected to one side of resistor R41, and if that is connected to pin 17 of the 74 LS240. And what I will do is I'll just put you in macro and I will show it on the screen, because you can actually see the trace over here. See, this is R41 and there is a trace that's going here to this pin of, this is the LS240. And we should be going to pin 17 of the LS240. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 indeed. So there you see the trace that's going to this side of R41, and that should also be going, you can't really see it, but to this LM339 pin 14. Am I viewing this correctly? Yes, pin 14. So 1, 2, 3, 4, 5, 6, 7. So that's pin 14 connected to pin 17. I should be on continuity test. It's connected perfectly fine. And I checked this when I replaced the LM339. However, it is not connected to this resistor. See, do you see somewhere here the break in this trace? Because I don't. Well, now I think I can see it, but I mean, this pin is not connected to that leg of the resistor. Unbelievable. So I'm bringing you again a bit closer. So there, see, there is the trace. You can see it clearly leaving that pin, going like that, and there to that resistor, but it's not connected. That is our problem. Yeah, sorry, I had to move you out of the way a bit, otherwise I can't reach it for soldering. So I still can't really see where it is broken. It has to be at the connection of the resistor itself. So I'm gonna lift the resistor out and then we'll see what's underneath. Let's add some fresh solder first. And let's get the solder out and see if we can see more of what is going wrong here. Yeah, that pad is simply, is it, where is the, there is no pad underneath that resistor. What the hell? Did the battery corrosion eat that entire pad? Oh, that would be spectacular. I don't know if you could see this, but let me just try to see if I can get you a bit closer. I don't know how well this shows up on camera, but there is absolutely no pad there. See? It is totally gone. I have no clue what happened here. Maybe this is a problem from the factory and this was only making contact very marginally, just with the edge of the trace. And now because of the corrosion, that contact broke. I have no clue how this happened. Very weird. So what I will do here is I am going to simply make a bodge wire. And I am going to apply this bodge wire here on the back side of the PCB because that's much easier, of course, to solder it. The tape is just there to hold it in place while soldering, so to make sure that if you solder one side and then you solder the other side, that the first side doesn't come loose again. Okay. Honestly, I think that's it. Okay, let's see if we have continuity now, like we should have. R41 here to there. Yep. And from there to, which pin was it over here? Yep. Okay. Yeah, let's put this back in the machine and let's see if it works now. Okay, the board is back in for the third time and let's hope the last time. And yeah, again, only the direct switch is connected and let's see if it works now. Machine boots. That sounds fine until now. Now let's see if we still have the same issue. I guess not. Let's go into the test menu. Switch edges, and then if I press some buttons, they are only triggering the button that I'm pressing and not this ghost button anymore. Awesome! That is exactly how it should be. Let's go to the switch levels. No switch is registering. That looks already a lot more healthy. Now let me hook up the rest of the switch matrix. Okay, let's put this back. And now hopefully this machine should fully work. Switch edges. We have lots of switches. And let me just push some random things here on the playfield. Now, see, this menu is showing basically which switches are closed at the moment. And there are lots of switches showing, which is not necessarily an issue because there are lots of optos on this PCB. And if I remember correctly, they always show in the inverse way. So they are always show closed, and if a ball goes through, they go open. See, if I move my hand here, nothing is happening. No, if I move it there, see that one over there, it opens up when a ball goes through. It's normally closed. And this entire right column, those are the optos that are in the ball through. So this machine takes 6 balls, which are now at the moment not in the machine. So these, all these switches, they are all, let's say, open because the light is passing. because the balls are not in place. Normally, if I put the balls in the machine, then you should see these switches closing in that column. See, that is the ball, well, going through all the switches. Next ball, next one, next one, next one, and ball number 6. That's fine. At first sight, I'm just going to push some more random stuff here. See, I think, yeah, it looks like everything is working. I also don't see like an entire row or an entire column which is acting weird, because that's sometimes an indication of an issue on the PCB. So I think I'm going to install a battery, set all the settings correctly, and then I can play a game, I guess.
Lawmaster computer online. Welcome aboard. Range deactivated.
Warning for smoking.
Right ramp.
I wonder what's out there. Interesting. Dredd to control. I'm in pursuit of a stolen vehicle. I am here for kidnapping.
Shoot, sniper time.
I'm here for kidnapping.
Battle tank damage at 25%.
Dredd to control. Battle tank destroyed.
Civil disorder has erupted in MPU.
Shoot, right ramp.
Well, that's it. The machine is fixed and it plays quite well. And then you see how such a stupid mistake can really ruin your day, because I spent most of the weekend here fixing this thing. If I just would have, well, taken the time once a year or so to check the batteries, it would really have saved me quite a bit of work. Now, this battery holder that I put in there at the moment is only temporary. I put the coin cell in there. I know it's not gonna last that long, but I plan to upgrade the PCB to non-volatile RAM, and then I should never worry about batteries again. Now, there are still a couple of small things that I need to fix on the machine. That ribbon cable, for example, that I need to swap. But hey, that's owning a pinball machine, because if you own a machine like this, be prepared to constantly fix things because there is always something that is not working perfectly fine that needs to be adjusted or that needs to be fixed. But for me, that's part of the hobby. I really like to do these things. So I also hope you enjoyed the video. It was something quite different from my usual videos. Next video will probably be back again to some more audio related things. But hey, if this video does well, maybe I can pop in some pinball and arcade stuff from time to time on the channel as well. So yeah, anyway, hope you liked the video. I'd like to thank you for watching and I'll see you next time. Take care. Bye bye.